Welcome back to the channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P, probability. Auto-claim amounts in thousands are modeled by a random variable with density function equal to x times e to the minus x for x greater than or equal to 0. The company expects to pay 100 claims if there is no deductible. How many claims does the company expect to pay if the company decides to introduce a deductible of 1,000? So, of course, I can't resist trying to use the Darth Vader rule for the solution. For what we're looking for is the crucial piece of information is the probability that x is more than 1 for this random variable, which is the integral from 1 to plus infinity of x times e to the minus x dx. And recall this Darth Vader rule version that expected value of the maximum of x and a is a plus the integral from a to plus infinity of s sub x of x dx, where s sub x is the survival function of this random variable. By applying this rule to an exponential random variable with hazard rate 1, we'll denote it by y, we get this. That the probability that x is more than 1 is equal to the integral from 1 to plus infinity of x times e to the minus x dx, because that's the density. And then we write this as the integral from 0 to 1 of 1 times e to the minus y dy, plus the integral from 1 to plus infinity of y times e to the minus y dy. We just changed x to y, that's it. But we're doing this so that we can refer to this random variable y, which has is assumed to have the exponential distribution with hazard rate 1, which means also with mean 1. And then we subtract the thing that we added, so minus integral from 0 to 1 of 1 times e to the minus y dy. And of course, then the first thing is the e of the maximum of expected value of maximum of y and 1. And we subtract the integral from 0 to 1 of e to the minus y dy. And that's actually the cumulative distribution function of y evaluated at 1. So the expected value of that maximum is 1 plus the integral from 1 to plus infinity of the survival function of y dy. And the CDF is 1 minus e to the minus 1. And then what we have is integral from first of all, we have 1 and 1 cancel out, so that goes, and minus minus e to the minus 1 becomes e to the minus 1 with a plus sign. And then all we have to do is calculate the integral from 1 to plus infinity of e to the minus y dy, which is the survival function of y evaluated at 1, which is e to the minus 1. So we have e to the minus 1 plus e to the minus 1, and it's 2e to the minus 1, approximately 0.7358. And now the company expected 100 claims when the policy had no deductible. We now see that if the deductible of 1,000 is imposed, among the losses that occur, there is only 0.7358 probability that such losses exceed the deductible. So it follows that the company now, with the deductible imposed, expects to have 100 times that probability, 0.7358, claims, which is approximately 74 claims, which is answer E. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.